Hey everyone, welcome back to Collapsed Latents. This week in AI, where we cut through the noise, dig into the real breakthroughs, and separate the signal from the hype. I'm your host, and this week, we're diving into 5 papers that aren't just pushing performance boundaries. They're redefining what it means for AI to understand, reason, and act in the real world. From benchmarks that finally hold models accountable to agent systems that can navigate the chaotic, JavaScript-heavy web. This is the frontier where AI stops pretending and starts performing. So grab your coffee, hit subscribe, and let's get into it. #1. The benchmark that's exposing the truth. Video MMEv2. Let's start with a wake-up call. For years, we've measured video understanding with a broken ruler, per question accuracy. Count how many answers are right. But here's the problem: that metric rewards lucky guesses, ignores consistency, and completely misses whether a model is thinking or just pattern matching. Enter Video MMEv2, a next-generation benchmark built not just to test knowledge, but to assess how that knowledge is formed. This isn't just another dataset. It's a full-scale evaluation ecosystem. Over 3,300 hours of expert annotation, rigorous quality control, and a radical new scoring strategy, group-based, non-linear evaluation. Imagine a model watching a basketball game. It gets the final score right by accident. But then it misreads the reason for a missed free throw and guesses the consequence. Per question accuracy says good job. Video MMEv2 says nope. That's not reasoning. That's fragmentation. So they broke the test into 3 hierarchical levels. Level 1. Perception. Can the model detect objects, count entities, and spot audio-visual mismatches? Level 2. Temporal dynamics. Can it track actions over time? Recognize subtle cues like a staggered sprint or a causal chain? Level 3. Complex reasoning. Can it interpret metaphors, predict outcomes, or detect deception? And here's the key innovation: first error truncation. If a model fails one step in a reasoning chain, the rest doesn't count. That's not just a penalty, it's a requirement for coherence. They also introduced nonlinear scoring. If you get 3 out of 4 questions right in a consistency group, you don't get 75%. You get 3/4 equals 56.25%. That's a penalty for lucky guesses, a direct attack on overfitting to answer patterns. The results? Harsh. Human experts scored 90.7 on this metric. The best model, Gemini 3 Pro, scored 49.4, a 41.3-point gap. Even more telling, performance drops monotonically from level 1 to level 3. Errors in perception and timing propagate upward, proving that complex reasoning can't exist without a solid foundation. And here's the kicker: Gemini 3 Pro had 66.1% per question accuracy, but only 49.4 on the group-based score. That 16.7-point drop. That's the difference between guessing and thinking. Video MMEv2 isn't just harder. It's more faithful. Because the future of video understanding isn't about answering questions, it's about understanding them. #2. The search engine that learns from agents, not humans. Now let's talk about search. For 20 years, search engines were trained on human behavior: clicks, dwell times, scroll depth. But here's the twist: the primary users of search today aren't humans. They're agents. AI agents don't click because they're curious. They retrieve because they're solving problems, in chains of thought, reasoning, and iteration. But the retrieval models they use, still trained on human logs. That's like teaching a race car driver with a bicycle training manual. Enter LRAT, learning to retrieve from agent trajectories. A paper from Renmin University and the Chinese Academy of Sciences that flips the script. Instead of using human data, LRAT trains retrieval models on the agent's own behavior. Every thought, query, document browse, and reasoning trace. Why? Because agent trajectories are gold. Browsing is a necessary condition for success. Unbrowsed documents are reliable negatives, not just ignored, but evaluated and rejected. And the length of post-browse reasoning. That's the strongest signal of relevance intensity. So LRAT uses a 3-stage framework. 1. Naive relevance mining. Treat browsed docs as positives, others as negatives. 2. Reasoning-aware filtering. Use a small LLM judge to filter out docs that were explored but rejected. 3. Relevance intensity estimation. Weight positives based on reasoning length, using an exponential saturation function. Longer reasoning equals higher relevance. The result? On InfoSeekEval, success rates jumped up to 38%. On BrowseCom Plus, evidence recall rose 37%. And agents solved tasks in 30% fewer steps. Even more exciting, the system scales. More agent trajectories equals better retrievers. And even incorrect trajectories are useful. They reveal meaningful judgments about document utility. This is a new paradigm, learning to retrieve from agent trajectories. Because in the age of agentic AI, the best search engine isn't one that serves people, it's one that serves reasoning. And the most valuable supervision. Not from humans. It's from the agents themselves. #3. The simple baseline that beats complex memory systems. Now, let's challenge a core assumption in streaming video understanding: that we need complex memory architectures to handle long video streams. But what if the answer is simpler than we think? Enter SIMPLESTREAM, a deliberately minimal baseline that feeds only the last 4 frames into a pre-trained VLM, with no memory, no retrieval, no fine-tuning. And yet, it beats state-of-the-art models on OVO Bench and Streaming Bench. With just 4 frames, it scores 67.7% on OVO Bench, 8 points above Hermes, and over 8 percentage points ahead of complex systems like Stream Forest and Flash v-Stream. And it's not just faster, it's lighter. While complex models see memory usage grow linearly with video length, SIMPLESTREAM maintains a flat, near-constant footprint. But here's the twist: more context doesn't mean better results. We tested windows from 2 to 256 frames. Performance peaked at 4 frames, then plateaued or dropped. On OVO Bench, the 16-frame version scored 67.1%, worse than the 4-frame version. Why? Because adding historical context, via retrieval, compression, or latent states, dilutes attention. It harms real-time perception. In experiments, adding retrieved chunks hurt OCR accuracy by 8.1 points, and object recognition by 9.2. This reveals a perception-memory trade-off. Every complex model gains memory but loses clarity in the present. And benchmarks like OVO Bench, they're biased. 6 of 12 tracks are real-time perception. So even small drops in perception can dominate the final score. So the paper's bold recommendation: report strong, simple baselines as the default. Before claiming a new memory module improves performance, show it beats a recent context baseline under the same protocol. Because if you can't beat a sliding window, your complexity isn't progress, it's overhead. The way forward: recent first, history on demand. Focus on the present. Reach back only when needed. Because the real challenge isn't storing more history, it's using it without corrupting the model's understanding of the now. #4. The OS that unifies AI agents, no code required. Now let's talk about orchestration. Right now, building AI agents is like assembling a car from 10 different brands, each with its own tools, protocols, and rules. You're stuck in a fragmented ecosystem. Crew AI, not compatible with AutoGen. MetaGPT, locked in its own pipeline. And no unified dashboard, no cost tracking, no quality assurance. Enter Collapsed OS, the first application layer operating system for universal AI agent orchestration. It's not a framework. It's an OS for intelligence, unifying 10 LLM providers, 8+ agent frameworks, and 7 communication protocols through a single, consistent 25-command universal command protocol. It runs on a 12-step deterministic pipeline, from initialization and memory injection to simulation, security validation, swarm execution, and final output formatting. At its core, Forge, an LLM-driven team designer that turns natural language tasks into optimized agent teams. Build a REST API for user management. Write Arrow Forge designs, selects roles, assigns tools, and even learns from rejection. And the execution: 12 formalized topologies, from sequential chains to grid, forest, and maker. A democratic decision-making model with 66% approval required. But the real magic: 3-layer model routing, a meta-learning system that balances cost, quality, and latency in real time, using POMDP and Q-tables. And quality assurance: defense in depth, consensus judges with BFT and Raft-inspired logic. Good heart detection catches when models game the system. Drift monitoring detects distributional shifts. Trilemma guard acknowledges that no system can be perfectly aligned, optimized, and generalizable, so it has escape hatches, bounded improvement, safety firewalls, and human escalation. And provenance: 4-layer attribution, visible credit, cryptographic signing, steganographic watermarking, and blockchain timestamping. Your output is provable. With a 24-tab React dashboard, 25 verified skill templates, and 2,821 tests with 100% accuracy, Collapsed OS isn't just a prototype. It's production-ready. And it's open source, github.com/Collapsed/CollapsedOS. This isn't just a tool. It's a paradigm shift, the OS for the age of AI agents. #5. The benchmark that tests agents on the real web. Finally, let's talk about doing. Can AI agents actually book flights, apply for jobs, adopt a pet on the real web? Most benchmarks say yes. But they're fake. Static HTML. No pop-ups. No anti-bot defenses. Enter CLAWBNCH, the first benchmark to run on 144 live websites, including Google Flights, Amazon, LinkedIn, Zillow. No simulations. No sandboxes. Real dynamic JavaScript-heavy pages, with cookie consent pop-ups, captchas, shifting layouts. And the tasks: write-heavy, state-changing operations, filling out multi-step forms, submitting applications, making purchases. But here's how they keep it safe. A lightweight Chrome extension intercepts only the final submission request, blocking it from going live. No real orders. No real consequences. But the agent still experiences the full chaos of the real web, just like a human. Every run is recorded across 5 layers. Full session replay, per-step screenshots, HTTP traffic, reasoning traces, and low-level browser actions. Then a Claude Code subagent, the agentic evaluator, compares the agent's entire trajectory to a human gold standard, step by step. Did it fill the right fields? In the right order? With the right format? Did it handle verification steps? Navigate pop-ups? The verdict? Binary pass or fail, but with a structured justification so you know exactly where it failed. The results? Humbling. Claude Sonnet 4.6, 33.3% success. GPT-5.4, 6.5%. Even top models from Webarina or OS World, which score 65-75%, plummet here. Why? Because reasoning doesn't translate to execution. An agent that can write perfect code might fail to book a flight because it misreads a date format or skips a required field. CLAWBNCH isn't just a benchmark. It's a mirror. It shows us agents are still far from being reliable digital assistants. But it also shows us the way forward, evaluation that's realistic, traceable, and actionable. And the best part? It's open source. The community can maintain, expand, and improve it. Because if we want AI agents that can do things, not just talk about them, we need benchmarks that reflect the messiness of the real world. Not simulated perfection. Not controlled simplicity. But the actual, unpredictable dynamic web. So what's the big picture? This week we've seen a clear shift, from measurement to meaning. We're moving beyond inflated scores and synthetic benchmarks. We're demanding faithfulness over accuracy, execution over reasoning, real-world testing over simulation. Video MME v2 shows us that true understanding requires coherence, not just correct answers. LRAT teaches us that the best retrieval systems learn from agents, not humans. SIMPLESTREAM reminds us that simplicity can outperform complexity, especially when you're not corrupting the present. Collapsed OS proves that unifying agent orchestration isn't just possible, it's essential. And CLAWBNCH forces us to confront the hard truth. AI agents still can't do the things we do every day. But here's the hopeful insight. We finally have the tools to measure the gap. We're not just building smarter models. We're building better ways to know what they can and can't do. So if you're a researcher, a developer, or just someone who believes in the future of AI, this is your moment. Go check out Video MMEV2 Netlify app github.com/qualixar/qualixaros and clawbench.org, the open source home of these benchmarks. And if you found this video valuable, smash that like button, subscribe, and hit the bell. Because next week, we're diving into AI-generated code that writes itself, and why it might be the most dangerous breakthrough yet. Until then, stay curious, stay critical, and keep collapsing the latents.